There are two model sets that I found to be particularly helpful for illustrating the behavior of traditional seismic trace attributes. The first set contains 7 models that incorporate no geologic tuning. Each model consists of 9 traces with a single reflection spike that's been processed in various ways. In the first model, the energy model, reflection strength increases from left to right, 100% on the left to 180% on the right. Bandwidth and phase remain constant. In the second model, the bandwidth model, the low end of the Ormsby filter remains constant, as does the F3-F4 interval. But here, the bandwidth increases linearly from left to right. In the third model, the phase model, phase increases from left to right by 30-degree increments, 0 degrees on the left to 240 degrees on the right. Bandwidth and energy remain constant. In the fourth model, the energy bandwidth model, energy and bandwidth vary as they do in models 1 and 2, while phase remains constant at 0 degrees. Next, in the energy phase model, energy and phase vary as they do in models 1 and 3, while bandwidth remains constant. In the bandwidth phase model, bandwidth and phase vary as they do in models 2 and 3, while energy remains constant. In the energy bandwidth phase model, energy, bandwidth, and phase all vary as they do in models 1, 2, and 3. So when examined as a set, these 7 models illustrate sensitivity of attributes to effects of processing with no tuning effects, that is, constant geology, variable wavelet properties. The second model set flips the variables. Instead of constant geology and variable wavelet properties, we now have constant reflectivity and wavelet properties, but variable geologic tuning in the form of 3 wedge models. The thickness in these wedge models varies from 0 milliseconds on the left to 50 milliseconds on the right. To model sub-resolution thickness, each wedge was filtered with a 0 phase, 8, 10, 40, 50 Hz Ormsby filter. In the Blocky wedge model, each trace contains 2 reflectivity spikes of equal amplitude but opposite sign. The top spike, amplitude equal to -1, is located at the top of the wedge. The bottom spike, where the amplitude is equal to +1, is located at the bottom of the wedge. In the second wedge model, that is the Blocky gradational wedge model, all samples within the wedge contain a reflectivity spike equal to amplitude of +0.1. Each trace also contains a reflectivity spike of amplitude -1 located at the top of the wedge. All samples outside the wedge contain 0 amplitude. In the third model, the gradational wedge model, all samples within the wedge contain a reflectivity spike of amplitude equal to +0.1. All samples outside of the wedge contain 0 amplitude. It is helpful to examine both model sets because seismic attributes respond to both processing effects and geologic effects. The first model set exhibits laterally consistent reflectivity but laterally variable signal properties. The second model set exhibits laterally variable tuning but laterally consistent signal properties.